All right. Hello and welcome back to the AI Research Roundup. I'm your host, Alex. Today is May 3rd, 2025. We're looking at an interesting ICLR conference paper called MaestroMotif, Skill Design from Artificial Intelligence Feedback, published just over 3 months ago on January 22nd. This paper introduces a method, MaestroMotif, that helps AI systems learn skills described simply in natural language, using LLMs to handle the tricky parts like reward design and coding. Okay, so diving into their findings. This first visual gives a really clear picture. It's a radar chart comparing performance across different NetHack task types: navigation, interaction, and composite tasks. You can see MaestroMotif, shown in blue, achieving much better zero-shot performance, significantly outperforming other methods. It really demonstrates the effectiveness of this combined LLM and RL approach for tackling these complex, language-specified goals without specific task training. Building on those results, this schematic really breaks down how MaestroMotif actually operates. Okay, so the agent designer provides the initial skill descriptions in language. Then, the LLM gets involved, handling the reward design based on interaction data, and also generating code for skill logic, like initiation and termination. Finally, reinforcement learning trains the individual skills using these AI-generated components and nicely maps out that core workflow. Following that workflow, this figure zooms in on the deployment phase. Okay, it shows how the LLM coder takes a natural language task description and generates Python code. This code essentially acts as a high-level policy, selecting the appropriate skill index based on the environment state. That index then tells the trained skill network which skill to execute next, enabling that zero-shot task performance we saw earlier. Okay, moving to the results. This table then details performance on some really complex multi-step composite tasks, like golden exit or level up and sell. You can see the descriptions are quite involved. And, well, the numbers speak for themselves. MaestroMotif achieves decent success rates, almost 25% on golden exit, while the baseline methods just completely fail, scoring 0 across the board. This really underlines the power of using that generated code policy for sophisticated skill composition. Okay, and complementing those composite task results, this table breaks down performance specifically on navigation and interaction tasks. So we see MaestroMotif again under zero-shot, achieving really solid scores like 46% on Gnomish Minds navigation, or 0.66 on transactions. Well, contrast that with the other methods listed. LLM policy, motif, embedding similarity, most are getting 0 or very close to it. It really reinforces the advantage of this AI-assisted design across different task types. Alright, so we've seen MaestroMotif works well, but how well depends on the tools used. This next figure looks at the impact of the LLM coder size. Okay, the x-axis shows different scales, 8 billion, 70 billion, and 405 billion parameters, while the y-axis plots normalized performance. Well, there's a clear upward trend. Bigger models, specifically Llama 3.1 405B, lead to significantly better results, highlighting the importance of capable code generation. So that scaling with LLM size really underscores a key point here. Okay, wrapping up, MaestroMotif shows a really promising path by combining LLM intelligence for reward and code generation with RL for actual skill execution. This blend is crucial for achieving that strong zero-shot performance on really complex language-described tasks. Like we saw in NetHack, it's a powerful demonstration. That's all for this week's AI Research Roundup. Thanks for tuning in.